Hi, everyone. Thanks for coming back again. Today we have Ken Shoulders number 20, and we have Lacey reading something pretty interesting because this paper was written by Ken Shoulders and Jack Serfati. And I know that Frank Chili, who Lacey has had a lot of contact with recently, knows Jack Serfati as well. So I haven't read this, so let's dive into it and see what's in here.
Yeah. Energy conversion from the exotic vacuum revised. Abstract. A connection is shown between electron clusters or EVs and energy conversion processes yielding thermal energy in excess of the input energy used to form the electron cluster. Energy conversion process is traced to all known forms of cold fusion claims for overunity or excess energy production. A theory of like charge binding, as well as highly effective nuclear acceleration using the charge cluster, is presented based on local gravity coupling arising from manipulation of the exotic vacuum. Prologue. In earlier papers by Shoulders, it was shown that electrons could be clustered far beyond the densities normally allowed by classical considerations of charge repulsion. This dense state of charge clustering has produced a range of electronic devices with properties surpassing those of any other known technology. In addition, many new manifestations of anomalous energy production were shown on a laboratory scale. Although these energy gain measurements satisfied the numerous tests applied to them, they were unsupported by any theory due to their extreme divergence from classical considerations. During the search for a highly advanced space propulsion system, Sarfati originated a theory converting many aspects of a new physics based on manipulation of the exotic vacuum that appeared relevant to the measured energy gain arising from charge clusters, or EVs, herein called exotic vacuum objects, or EVOs. This writing is the first attempt to combine theory with practice on this new frontier of both physics and engineering as applied to new energy production methods. From present observations, it appears likely that future considerations will cover not only energy production processes, but totally new experimental propulsion methods as well. EVO formation and characteristics. In the simplest of EVO formation methods, electrons are extracted from a conductor by quantum mechanical tunneling when applying sufficiently high fields to exceed what is termed the space charge limit of emission. In this trans-space charge region, electrons are emitted as a coherent stream of fluid having number densities equal to that of the conductor lattice template, being in the region of Avogadro's number. The fluid-like properties of this emergent stream, along with incidental electrodynamic forces, determine how much emission occurs before quenching. Hence, the size and spherical shape of individual emergent EVOs, as well as the stream flow properties producing the bound and entwined groups of entities emitted. In this scenario, the foundation properties of the EVO always existed within the confines of the conductor lattice. When the electron substance is pulled from the lattice by intense fields, a new container form must be found. Sarfati in Appendix 1 through 3 presents the formulation of an adequately valid theory for this containment for the first time. EVO interaction with solid material. As shown in the paper by Shoulders, EVOs have the ability to bore clean holes through a wide range of solid materials and either forcibly eject the material as a fluid or withdraw it back to the initial borehole through a sloshing process due to electromagnetic mismatch of the EVO itself. In the same reference, it was shown that large quantities of ejected material could reach velocities of nearly 10 to the 8th centimeters second per second. An astonishingly high value for the small input energy used. No explanation could be given at that time for the measurements other than that an apparent reduction of mass was somehow in effect while the substance was embedded within the EV control arena. An alternative explanation is now available through manipulation of the exotic vacuum to explain the increased energy of the propelled particles. Once the increased energy of the material slug is imparted to the lattice of surrounding material through momentum transfer, an overall energy gain is achieved that is the foundation for the anomalous energy gain seen in all types of cold fusion processes. Again, Sarfati has presented a theoretical formulation for this apparently anomalous behavior in Appendix 2 by couching it in terms of the exotic vacuum behavior afforded EVOs. Energy production using EVOs. One of the better known fields of endeavor for the production of anomalous energy is called cold fusion. This field is divided into segments having apparently distinct properties, but in fact rely on only one basic process allied with EVO usage. The nominal divisions of cold fusion are electrolytic, sonically produced bubble collapse, gas discharge, and thermal cycling. Tests for EVO involvement in each of those divisions were run by Shoulders and found to contain conclusive evidence of EVO action. The EVO production process used in each division was different, but the end result was the same. Namely, the EVO converted material to a fluid and transported it at high velocity into the lattice of the experiment where the momentum energy was recovered as heat. The following SEM images were selected from reference 8 generated by Shoulders. This 350 megabyte CD shows many examples of EV involvement in various cold fusion processes. Figure 1. SEM of the underside of an electrolyzed palladium nickel film produced by George Miley and associates at the University of Illinois. Boreholes near circle are shown passing through the film particles and then turning and running laterally along the surface of a supporting alumina substrate in typical EV fashion. The approximate size of the boreholes shown is 0.2 micrometers in diameter. And then this on the picture says low penetration of thick film grain. Figure 2. SEM photo of the top side of an electrolyzed palladium nickel film produced by George Miley and associates at the University of Illinois for cold fusion measurements. Boreholes can be clearly seen as a fuzzy surface, covering that is probably a polymer growth developed from plastic bag storage over the 1 year time before SEM analysis. Figure 3. SEM image of a PD electrolytically prepared cold fusion sample by John Dash and associates of Portland State University. The view is taken from the edge of the sample showing a surface layer of active metal in the form of electroplated fibers with many boreholes produced by EVO action. Most boreholes are accompanied by a metallic splash surrounding the hole indicative of EVO penetration. Figure 4. SEM image of a niobium foil processed in a low-pressure electrical discharge of hydrogen by Tom Claytor of Los Alamos National Laboratories. The process simultaneously grows a black, low-density coating of niobium that is concurrently bombarded by EVOs ejected from a nearby cathode. This type of black coating is very interactive with EVOs and capable of high energy gain. The process was used for the production of tritium instead of for energy gain measurements. Figure 5. SEM image of coconut charcoal coated with PD to form a case sample for a thermal gain measurement by Mike McHuber of SRI International. The bright pieces of material often seen clinging to the edge of holes are usually the remains of palladium after thermal processing of the sample. The palladium film is blown off the surface by EVO activity, thus limiting the lifetime of the sample. Coconut charcoal has many natural holes in it, and it takes experience to determine which is natural and which is EVO bored. Spherical deposits nearby are the best clue that hole that the best clue the hole was EVO bored. Figure 6. SEM image of a portion of a palladium wire embrittled by heating in hydrogen sample was originally prepared by Franz Tanzella of SRI International to measure charged particle emission products while thermally cycling the sample. The sample is almost totally destroyed on its surface, where the embrittlement took place due to bombardment by EVOs. The bombardment process took place when the wire was thermally cycled to produce strain with resulting fractal emission and EVO creation. Figure 7. SEM image of palladium subjected to ultrasonic energy in a fluid bath by Roger Stringham of Woodside, California. This example of cold fusion work shows the widest variety of strike marks on the surface of any process known. It is suspected that a classic cavitation process causes some of the larger marks, while others are legitimate EVOs. A micron marker has been added to show the approximate scale of the sample. In all cases, the presence of EV, hence EVO, strike marks on the electrode signaled the presence of a workable energy generation process. The efficiency of each process is regulated by the efficiency with which the EVOs generated and used. As shown in 4, EVOs traverse high resistance material easier than highly conductive material, and the energy gain is higher for the former due to the larger quantity of material transported. Engineering considerations. The process of energy generation using EVOs is essentially one of devising a sacrificial structure or component based on first the formation of an EVO from external energy source, and then its destruction during the energy gain portion of the process. In line with this statement, deriving a thermal energy output inherently implies the need for an efficient reconstruction process to some useful equilibrium state. Such regenerative processes are seemingly feasible, but none have yet been adequately demonstrated when the output power density is high enough to yield a practical device. And then these are references.
Yeah.
Appendix 1. The direct gravitational effect of zero-point energy should not be confused with the quantum electrodynamical Casimir force, which is also a negative power law and may be repulsive depending on the shape of the EVO charge distribution. Indeed, the direct gravity effect will need to counteract the Casimir force in such a case. The general idea is that zero-point energy manifests in two qualitatively different ways using different equations of physics, from one general relativity, the other from quantum electrodynamics. Previous theorists in this subject have not been aware of this important distinction. Appendix 2, exotic vacuum acceleration of particles. The parameter Hg, there's an equation there, is of order 10 to the negative 26 power centimeters squared, i.e., and then there's an equation when n equals 1. For the internal structure of a single spatially extended electron. G star is scale dependent and must be determined empirically at this stage of a development of theory. The observed anomalous acceleration of EVOs is essentially the Alcubierre warp drive effect, where there are configurations of both positive and negative equation and different parts of the same EVO, causing it to self-accelerate. In terms of Alcubierre's exotic source parameter, and then this says the warp drive, hyperfast travel within general relativity. Miguel Alcubierre, Classical Quantum Gravity 11, 1994, L73 through L77, Appendix 3. a more complete model of the EVOs, including rotation and Casimir forces. Virtual photons of all three independent polarizations do have positive energy density, hence negative pressure, since W equals -1 for them. Since the gravity influence of the pressure is 3 times larger than that of the energy density, these virtual photons do anti-gravitate. The virtual photons in a static column electric field, or even in time-changing, non-radiating near induction fields, like in electrical equipment, are the macro-quantum coherent states as shown. For example, by Roy Glauber at Harvard in the early 1960s. These virtual photons are not part of the vacuum zero-point fluctuations. They are part of the ordinary stress energy density tensor on the RHS of Einstein's field equation. And then there's an equation there. I.e., macroscopic near EM fields only appear in the T UV term, not in the, and then there's another equation term. Since G slash C to the fourth equals 10 to the -33 powered centimeter per 10 to the 19th GeV, at least at microlab scales, we can ignore the direct effect of such classical EM near fields on the metric engineering, i.e. shaping of G UV, which comes entirely from the term. That's the key idea for practical metric engineering, the fabric of space-time for reactionless or propellantless propulsion. Metric engineering is strictly virtual without forces in the above sense. The idea of metric engineering is for the ship's crew to control their own time-like free float geodesic with small tidal stretch squeeze distortions and using small amounts of onboard power. Consider a spatially extended Bohm Vigier hidden variable model of an electron as a thin shell of electric charge at radius r equals e to the second power slash mc to the second power 1 Fermi 10 to the -13th centimeter. Ignore rotation or spin for now. Think classically, which is okay for the IT hidden variable and Bohm's pilot BIT wave model of NRQM. Relativistic Bohm QM requires teleology to explain ERP non-locality in a covariant way as the Feynman zigzag of Costa de Beauregard and later John Cramer, taken from Wheeler and Feynman in its first historical incarnation of classical electrodynamics. Action at a distance along both light cones advanced from the future and retarded from the past. The self-Coulomb repulsive barrier potential energy is of order of magnitude. Note the plus sign. The gradient magnitude is -e to the second power slash r to the second power, but the force is the negative gradient, hence the force points radially outward. Then there's an equation there. The repulsive QED ZPF Casimir force for a thin spherical cavity comes from a ZPF potential energy. Therefore, the QED repulsive Casimir self-force on the electron modeled as a charged spherical cavity is much stronger than the self-Coulomb repulsion. The general relativity quantum pressure correlation and the partially coherent exotic vacuum core of this spherical shell must be strong enough to cancel the repulsive Casimir force. The GR rule for the W equals -1 ZPF quantum pressure is to replace G, effective mass density P of real or virtual stuff, 1 + 3 W by C to the second power, and then the rest of that equation. I neglect factors of pi, etc. Assume a uniform 0-point energy density. There's an equation, core inside the electron charge, thin spherical shell. The effective 0-point induced self-gravity dark energy, potential energy per unit test mass, is then the harmonic well bag potential.
Mm.
Note that potential energy per unit test mass has dimensions velocity to the second power. The simple harmonic oscillator R squared dependence is same as drilling a hole through the center of the earth and dropping a bowling ball down through it. Note the counterintuitive result that the general relativistic 0-point fluctuation exotic vacuum potential must be positive, i.e., dark energy with negative pressure, to stabilize the electron as a thin shell of charge. All of the energies are positive. The Coulomb, Casimir, and rotational centrifugal barriers energies and the rotating frame are also all positive, but they decrease with increasing R, whereas the general relativistic 0-point energy increases with increasing R to make a potential well of stability. This solves the 100-year-old Abraham Becker Lorentz self-stress problem for the stability of the electron as a spatially extended hard massy object in the sense of Newton and Bohm. The electrical potential energy per unit test mass, including the repulsive QED Casimir force, is this equation. Note that that equation can be 0, positive, or negative.
Mhm.
Here, of course, the test mass equals source mass, i.e., self-energy. The dimensionless extended structure coefficients of order unity are N1 and N2. Suppose the electron is rotating with angular momentum J. The centrifugal potential energy per unit test mass in the rotating frame fixed to the electron is then this equation. Therefore, a larger equation. A necessary condition for stability, that is the total force negative gradient of the potential per unit test mass, vanishes. This is an a priori calculation of the weak force scale mass of the W bosons, 10 to about 10 to the second power GeV. I know again that that equation is required in this particular model. This means a dark energy core, not a dark matter core. This counterintuitive result is because we assume a uniform volume core of 0-point energy density and a thin shell of charge at the periphery. The sign of ZPF is highly model dependent.
Wow. Thank you, Lacey. That's awesome. You did such a great job reading that. One of the things that really stuck out to me was where they said they talked about the well, um, the Coulomb and Casimir and rotational centrifugal barrier energizes in the rotating frame are also positive, but they decrease with increasing R, whereas the general relativity 0-point energy increases with increasing R to make a potential well of stability. So that potential well of stability was something that I kind of wanted to bring up because that's right out of subquantum kinetics. And Lacey, yeah, you've got it on exactly the right page. This warp drive basically that is here is not really the metric that subquantum kinetics uses, but this model really describes what is happening as far as subquantum kinetics goes. So what ends up happening is we create a well or hole at the front of the ship or whatever we're trying to move, and then we create a hill behind it, and the ship actually starts to free fall into the hill while being or into the hole while being pushed by the hill. But it's analogous of a surfer grabbing a wave and riding the wave essentially. So I've said to Chris Beskar in the past that the best way to describe this is we swim them through the ether, essentially. So that's kind of what we're doing. So this is really cool. Does anyone else have any comments or questions about this?
Could you go back one page, Lacey? I wanted to see Appendix 2, where they read this again, just blow it up a little. Internal structure of a single spatially extended electron, scale dependent, determined period of the stage of development. Observed anomalous acceleration of EVOs, essentially a Cuvier warp drive effect. So here he just coupled EVOs with the warp field.
Yep.
Am I reading this wrong? This is amazing.
Yeah, no, this is and
Sarfati. This is what Ken was alluding to, I think, all those years, but wasn't willing to take the step. So I'll give some credit to Sarfati on this. He took the next step.
yeah, and I will too a little bit too, because Frank Chili years ago gave me a thick thing with all of Jack Sarfati's stuff,
Yeah.
and I've actually never really looked at it. But I think I might actually go back and have a look at it now. So I do give him some credit as well. And you know what they're talking about here too, in this appendix 2 was
It's
a
plus
negative.
and
Yeah,
yes,
exactly. Yeah,
it's positive and negative.
you
So
read my mind. Yeah,
the EVO field, the Alcubierre warp drive effect, where configuration is both positive and negative. That's the gradient. That's Einstein's gradient,
yeah,
for the 0-point energy field in different parts of the same EVO, causing it to self-accelerate. Holy shit! So you have a stable, non-dissipative EVO that is potentiated stably
yeah.
and is causing an internal self-acceleration. How the fuck does that work? That's seriously cool.
Very cool.
That's the magic barbecue sauce for a warp drive right there.
Yeah, exactly. That is exactly right. Yeah. And I think again from subquantum kinetics, if we dove into Paul Laviolette's work, it makes a little bit more sense in the fact that all he's really talking about are hills and valleys. And if you think about it, the topology of Earth is essentially that, especially if you look at the mountains, right? We've got all these hills and valleys and gradients in between, because it's the gradients that are also the important part, right?
God,
Yeah.
could this be a black and white EVO gradient potentiation? You think positive and negative? I mean, when you
Yeah.
talk about, I'm still not sure what a black and a white EVO is.
Well, you know what? Lacey actually asked Chris Beskar on our last interview about that. the black, or we're specifically talking about how it can go in as a black EVO and then it'll transmute and come out the other side and create all of these different things as a white one. But you know what? Chris didn't even go there with black and white.
Jesus. So
Yeah, Lacey, do you remember that?
Yeah, I do remember that.
Yeah, and I don't
so
know.
that's got to be magic sauce, right? You can't talk about it.
Yeah,
he was really like he knew
Pushing back on
about
it.
the white EVO, but he like looked at the black EVO because I was like I said, like we understand that this is like a singularity,
yeah,
a black EVO. And he was
yeah.
like, oh, really? And he was like kind of looking at it and he's like, yeah, like that's where you get into like portals and teleportation.
God.
He did say that, and what it was that picture that from John Hutchison's experiment that they had recreated, and there's this black, looks like a black hole, but I'm going to call it a black EVO, and then on the other side there was a white one, and Chris said, yeah, I understand how you could get the white one. He said, basically that, but then he said exactly what Lacey just said there. Could it be a portal? And understanding of things is it's the amount of voltage, negative voltage that you use, and the amount of vacuum, how hard the vacuum is, that determines whether these things are black or white. But yeah, I think it was sensitive area, because Lacey asked me later, like, why didn't he, go into that a little bit more? But I think Chip just said it's the magic sauce, it's the barbecue sauce. And it's part of our research here is to try and figure that out for sure.
Yes.
Yeah.
And so it's self-potentiating, yet stable. And it's stable because of the reciprocity, it would appear. And that's makes sense. In terms of Akui's exotic source parameter, TRK is approximately equal to the gradient field, ZPF. So what Sarfati has done is stabilized EVOs for Ken Shoulders, created a potentum, potentiated an EVO, a stabilized EVO field that is negative and positive, and is then to find as Alcubierre's warp field. That's amazing.
Yep.
I'm working with some guys in Salt Lake. I think I referred to this once before. Cal Richardson supposedly built a pink Volkswagen that went to the moon years and years and years ago. And it was an EVO bubble that he built based on a magnetic motor design as the engine for the thing. And
Yep.
so this is very interesting. These guys in Ogden are going to start rebuilding this based on blueprints. We actually have blueprints for
Oh,
it.
cool.
And rebuild the whole thing. And essentially this thing has got a little warp field around it. Amazing.
And the other day I was showing Lacey, we watched Mastering Getting into Space, which is a thing basically about the Russian hover car program and their technology. And there's one point in there where they actually show, they start talking about the Ajax, which was the Russian classified space plane, essentially. And they actually show the vacuum plasma bubble sheath as we know it. This is the proper terminology. They actually show it forming. You remember seeing that, Lacey? That was so cool.
Yeah.
Yeah. Yeah. We should actually probably do one of those things in this group. Go through and maybe get some slides and go through something, because there's a lot of really rich information in there. But yeah, it would appear that Jack Sarfati and Ken Shoulders have actually sort of nailed down the math and some of this. Now, I will say this, that because this is a subquantum kinetics group from Paul Laviolette, subquantum kinetics looks at the math a little bit differently, and it's actually more simplified in some ways, but not really, because it's an open system. So there's a lot more things going on. But certainly the math that Jack has got going on here, I'm sure, almost positive, also works as well. It's just a little bit more complicated. And it's not something that a 5-year-old's going to be able to comprehend. But with subquantum kinetics, one day we hope that there will be a book or a textbook that 5-year-olds can learn about subquantum kinetics.
And I like to see that obviously Sarfati is familiar with the quantum vacuum, the ZPF field.
Yeah.
And here they have activated, used it to create this potentum. Usually it just sits there until you torque it, pinch it, or poke it.
Yeah,
It doesn't do anything, it gives you energy. But
that's
now
right. Yeah.
they're leaning on it as the stability factor, looking outside of Einsteinian relativity.
You have to.
Using the vacuum field to create a stability that allows this gradient reciprocity with a stable EVO, which is the freaking warp field. Amazing.
Yeah. Isn't it? Yeah, this was a good one. I've been waiting a little while to do this one.
This is my favorite so far.
Is it? Yeah. It is definitely a good one, because it kind of puts all the concepts together and all into one place, so to speak, right? So,
well, who isn't interested in propulsion? Ultimately, let's build a starship that goes really fucking fast.
Yeah, exactly. Well, very cool. Does anyone else have any comments, or should we stop the recording? Okay, well, maybe we can do that, Lacey. We'll stop the recording and we can talk a little bit more about it.
Yeah.
Thank you again. That was amazing. You're letting us read it to us.
Yeah. Thanks for letting me read it.
Mm-hmm.